Hi everybody, welcome to my Q&A. This is, video number 2 of our arithmetic series. Well, please note that at this point, we have actually now explained and described the general formula of our arithmetic sequence. Now, we want to actually apply this on an actual sequence. Going back to our simple sequence, 2, 4, 6, 8, all the way up to infinity, we can actually show that this equation, if we sum the values, it can be represented by an arithmetic sequence. Now, let's confirm that this is actually an arithmetic sequence. Well, 4 minus 2, 6 minus 4, 8 minus 6 are all equal and all are 2. So this is an arithmetic sequence. What if now we want to add the terms? So we say 2 plus 4 rather, and then summing them. We don't just have commas going forward. We actually summing them. 2 plus 4 plus 6 plus 8. Like I said, an arithmetic sequence, when you say Sn, if we say S10 there, we're actually saying what is the sum of all the values from the first term to the 10th term. And be aware also that now the first term is term number 1, not term number 0, term number 1, and then this term number 2, 3, 4, 5. Now, based on this equation, Sn, n over 2, 2a, n minus 1, d, I've actually explained what all these variables mean. Now, let's go now and actually use this series that we have and populate that equation. Let's get the equation of the sum of this series. So Sn is going to be n over 2, and then 2, and then from there, we actually substitute a by 2, because a is our first value. Okay, a is our first value. Then from there, we say plus n minus 1. Okay, plus n minus 1, where n minus 1 is just there. We don't replace n minus 1. And then from there, we've got 2. 2 is our difference. Okay, now from there, let's go and solve this equation and actually see what is our last equation. Preferably, well, that is actually an answer. There's a correct equation over there, but it's not preferable for you to leave this equation like that. You must solve it further. Okay, sorry about that. Well, now let's continue with our problem. Now, so we had Sn equal to n over 2 multiplied by 2 multiplied by 2 plus n minus 1 times 2. Now, let's solve this equation using our equation rules. So we've got Sn is equal to n over 2. Let's solve what's in the bracket first. 2 times 2 is 4 plus 2 times n is 2n. 2 times 1 is minus 2. Well, 2 times minus 1, rather. And then Sn is going to be equal to n over 2. Now, 4 minus 2 is 2 plus 2 plus 2n. Now, Sn is going to be n over 2 times 2 is n plus n over 2 times 2n is n squared. So, our final equation is actually n squared plus n. Please note that we prefer writing this thing with the n with the highest exponent first before the 1 with the lowest exponent. So that is our last equation. Don't forget that the series we're actually talking about here is 2 plus 4 plus 6 plus 8 plus 10 all the way. Please note that this is term number 1. This is n 1, 2, 3, 4, 5. Now, let's see, using our sum equation, if we'll be able to find a specific term. Don't forget that I said the Sn, whatever the value of n is, it says that let's find the sum of all the values starting from 2 all up till the specific n you're talking about. So let's sum all the values from the first one all the way to whatever n you're specifying. Let's find all these values. Let's just prove that this equation is correct by saying, well, let's find the sum of these values up to the third term. So which means we're going to say S3 is going to be equal to 3 squared plus 3. Now 3 squared is 9 plus 3 is 12. That is something we can prove. I said that let's find the sum up to 12. The sum up to the third term. Let's prove this. I think it's pretty straightforward, and we actually all are aware and we know that if you sum 2 plus 4 plus 6, 2 plus 4 is 6, 6 plus 6 is 12. And that is the answer that we got. Let's do another simple example. Let's find this up till, well, the 1, 2, 3, 4, 5. The fifth term. S5 is going to be equal to 5 squared plus 5. 5 squared is 25 plus 5 is equal to 30. Now let's go and sum this up till the term and see if we get the same value. 2 plus 4 is 6 plus 6 is 12 plus 8 is 20 plus 10 is 30, and that is what we have here. So now you can see that this equation gives us a sum of the arithmetic series from the first value to that specific value. Thank you.